Hi everybody. So this is the video for Unit 3 Lesson 5 or 3.5. And today we're going to get into something called factoring. So we are going to be doing factoring for the next 4 lessons. So we're going to be looking at 4 types of factoring. And so today obviously is type number 1, and I just call it removing the GCF. And remember, GCF stands for greatest common factor. We've talked about that a little bit. So I'm just going to do a review, as I usually do, of what we learned in the last lesson. So in the last lesson we did a review, in the last lesson we multiplied polynomials together. We had some big complicated questions, but right now I'm just going to do a fairly simple question, and I'm going to review multiplying a polynomial by a monomial. So just one term on the outside. And as you guys should remember, we just distribute and multiply. So 3 times 5 is 15. And then remember, we add the exponents together. So because there's that 1 on that x, 2 plus 1 is 3. Moving on, 3 times -6 is -18. And then I have an x squared y. Remember, I can't add those together. They're two different letters. So I just smush them together instead. And then finally, 3 times 2 is +6. And then between those two terms, I just have x squared. There's nothing to add to it. So what factoring is, you guys, is actually going backwards. So we just did multiplying, right? We took that expression up there, we distributed, and we multiplied. Factoring is going backwards. So factoring is the opposite of multiplying. So factoring a polynomial means undoing the multiplication, or opposing the multiplication, going backwards. To do this, we need to determine the greatest common factor among all of the terms and divide it out. So just one more thing before I get going. So all of the questions today are going to look like this. So I give you this part. It's like I give you the final answer, and your task is to work backwards and figure out what was the question. So I want your answer to look like this today. You're going to give me what the question originally was. So we're just working backwards. Okay? So first of all, we're just going to practice determining the GCF between a couple of terms. So the GCF is the greatest common factor. So the biggest thing these two guys have in common. So what can I divide 15 by that I could also divide 3 by? Well, the answer is 3. I can divide 15 by 3, and I can divide 3 by 3. Okay, I could divide 15 by 5, right? But I can't divide 3 by 5, so that wouldn't work. So 3 is the biggest common factor that can be divided out of both of those. On to the next one. Now I have letters attached as well. 18x and 6x. Okay, so first look at the numbers, 18 and 6. What can we divide 18 by? Well, we can divide 18 by 1, 2, 3, 6, 9, and 18. If we list all of the factors of 6 as well, we can divide 6 by 1, 2, 3, and 6. So they're both able to be divided by 6. So that's the greatest common factor. Yes, they can both be divided by 3, but that's not the greatest common factor. They can both be divided by 6. Okay, now we're not done, because look at the x's. They each have an x to give. So because that's common to both of them, we can take it out. So we would divide out a 6x. That's the greatest common factor. Okay, -49y squared and -7. Whenever both terms have a negative, that's common, so we can take it out. So we're looking for anything that's common. Okay, looking at 49 and 7, what can I divide both of those by? Well, 49 can only be divided by 7 or itself, 49. Now we can't divide the other 7 by 49. So the only number I could divide into both of those is 7. Okay, now look at the letters. Let's look closely. One of them has y squared and one of them has y. So this first guy has 2 y's, but he only has 1. So they actually only have one y in common. I cannot take two y's out of him because he doesn't have two to give, but I could take one out of each. So that would be the common factor I could divide out of both of those. And finally, one last one for practice before we actually start the real questions, 10ab squared c and 20ab. So look at the big fat numbers first, 10 and 20. I could divide both of those by 2, both of those by 5, and both of those by 10. So the greatest one is 10. I wouldn't choose 20 here because I can't divide 10. I can't divide this guy by 20, so I'm not going to choose that. Now looking at the letters, they each could give me an A, that's common. They each could give me one B. This guy has 2 to give, but he only has 1 to give, so I can only take 1. And then if we were in class, I would say, could I take out a C? He has a C to give me, but the next guy doesn't, so there is no C in common, so I can't take it out. So the greatest common factor would be just 10ab. Okay, so now we're going to actually get into completing the questions. So the instructions here say factor the following polynomials. So this is the final answer to something, okay? We have to go backwards and say, well, what was the question then? What question gave me an answer of 6x plus 9? So what we do is determine the GCF. So step 1, determine GCF. So the GCF of 6x plus 9. So what can I divide 6 by that I could also divide 9 by? 3. And I write it down. Now, could I take an x out of both terms? The 6 has an x to give me, but the 9 doesn't. So no, it's not common. The only factor common between these two terms is 3. So because I found the only thing that's common, I write it down. Now I open a bracket. In step 2, divide each term by 3. So I start with the first term, 6x divided by 3. Well, 6 divided by 3 is 2. And then I didn't take out an x. I'm not dividing out an x, so he still has the x attached to him. And then moving on to the next term, positive 9 divided by 3. Well, 9 divided by 3 is 3. I'm done. I close the bracket. Now, you could always check your work here. You can always check your work by multiplying it back in. So 3 times 2x is 6x. 3 times 3 is positive 9. I know I did it right because it matches the original question. Okay? All right, moving on to B. So now I have 3 terms, 12c squared minus 6c plus 2. I have to find a common factor between all 3 terms now. So looking at 12, 6, and 2. Can I divide all of them by 2? Yes, I can. I can divide 12 and 6 by 3, but that doesn't matter because I can't divide 2 by 3. It has to be common to all of them. So the only number that's common, whoops, I'll go back to black here. The only number that's common between all 3 is the 2. Now I cannot take a c out because even though the first 2 have c's, the third term doesn't have a c to give me. So it's not common. I can't take it out. So all I can divide out is a 2, and now we just start dividing. 1 term by 2, 1 term at a time. 12 divided by 2 is 6. Because I didn't take out any c's, I still have c squared. Moving on, negative 6 divided by 2 is negative 3. Again, because I didn't take any c's out, I still have the c there. And then finally, positive 2 divided by itself, 2 is positive 1. Close the bracket. Now remember, you can always multiply this back in to see if you did it right. 12c squared minus 6c plus 2. I checked, it matches the original question. I know I did it right. Okay, so that verifying step is totally optional. Okay, C. Again, we have 3 terms, so we have to think of what's common to all 3. Now, this is just kind of a picky thing that I do, and the textbook does as well. So if you want your answers to match the textbook answers, you're going to do this. If the first term is negative, we always are going to take it out. It's just common practice, okay? So I'll repeat that. If the first term is negative, take it out, and I'll write it here. if the first, oh, what did I just open? That was weird. If the first term is negative, take out a negative. So that's what I did there. So I took it out. Okay, so now my numbers are 14, 7, 21. What can I divide 14 by that I can also divide 7 by that I can also divide 21 by? And it's 7. Okay, now xy, y, and x. Is there anything that's common to all three? All three of those terms don't have an x, so I can't take it out. And all three of those terms don't have a y, so I can't take it out. All I can take out is a negative 7. And so I get to work now. So I want you to be careful here because when you're dividing everything by a negative 7. So this first term, negative 14 divided by negative 7 would now be just positive 2 because a negative divided by negative is a positive. And because I didn't remove any variables, they're still going to be stuck there. Then a positive 7 divided by a negative 7 is a negative 1. And because I have a y there that I didn't remove, I still have a y. And finally, positive 21 divided by negative 7 is negative 3. And then because I had that x that I didn't take out, it just sticks with that 3 and we're done. Now, there's one thing someone might be thinking, is that 1 optional? That 1 is in fact optional. You could just write you could just write negative y if you wanted to, okay? Okay, this is where we're going to actually start to be able to take out letters as well, finally. So looking at this question here, you have 3 terms, and you should see that the first term is negative, so we're going to take that out. What can I divide 25 by that I can also divide 10 by, that I can also divide 5 by? They can all be divided by 5. That's the greatest number they can all be divided by. Now we got to look at the C's. Every single term has a C, but you can only take out one of them because this guy only has 1 to give. You can't take out 2 because he doesn't have 2 to give you. Okay, so they can only give you 1 C each before running out. Open up the bracket. Negative 25 divided by negative 5 is a positive 5. Okay, now this is where it's different. You have to listen carefully. You started with C to the 3, right? But we are taking out a C to the 1. So if you had C to the 3, but you took out C to the 1, you only have 2 left, right? So we're actually subtracting exponents now. Moving on. Negative 10 divided by negative 5 is a positive 2. Now, you had 2 C's, but we decided to take 1 out, right? So 2 take away 1, you only have 1 left. And that little 1 I just drew isn't necessary. And finally, positive 5 divided by negative 5 is negative 1. Now listen, I had 1 C, but I took out 1 C. So I have no C's left. So you just close it up. Okay, let's try another one. Again, in this these 3 terms here, sorry, the first term is negative, so we take it out. Now, 12, 20, 16. What can I divide those all by? I could divide them all by 2. I could divide them all by 4. So I'm going to choose 4 because it's the bigger one. All right, now let's start it with our x's. We have lots of letters here. This first term has 3 x's. This guy only has 1 x, and he has 2. So you can only take out 1 because he only has 1 to give. So you always take out the lowest exponent. So between 3, 1, and 2 x's, I take out the 1 because it's the lowest. Now, y, y2, and y2. How many could I take out? Well, he only has 1 to give, so I can only take out 1. All right, you can't take out more than one term is willing to give you. Now we open up. Okay, and we divide. So negative 12 divided by negative 4 is now a positive 3. Now we have to do a lot of subtracting here. I had 3 x's, but I took 1 out, so I have 2 left. Now with the same term, I'm not done. Let's just look. I had 1 y, but I took out 1 y, so the y's are gone. 1 take away 1 is 0. It's gone. So now we can move on to the next term. Negative 20 divided by negative 4 is a positive 5. Now, I had 1x, but I took out 1x. I have no x's left. Go to the y's now. You started with 2 y's, but I took 1 out, so I have 1 left. 2 take away 1, you still have 1. Moving on. Negative 16 divided by negative 4 is positive 4. Now, whoopsies, I had 2 x's, but I took 1 away. Oh, sorry, but I took 1 away, so I only have 1. Same with the y's. I started with 2, but I took 1 out, so I have 1 left, and I close it up. And again, if you wanted, you could always distribute the negative 4xy back in and make sure you end up with that original question. Okay, F looks crazy. Lots of terms. And if we were in class, I would say, okay, what do these terms all have in common? And you guys would say, well, there's 6 terms and there's nothing common to any of the terms. I mean, 4 of them have x's, but the 2 middle terms don't have x's, so we couldn't take an x out. Okay, so in this case, we don't just move on and say it's impossible, because if we look closely, we can simplify similar terms. I have an x squared and a 5x squared, don't I? So I could rewrite those as 6x squared because there's actually a 1 there. So because they come from the same family, they're both x squared, you can just add the numbers out front. Okay, now moving on, I have 8x and another positive x. They're both x's. Remember, there's a 1 on that x. So really, I have positive 8x plus another 1x. I actually have positive 9x. And finally, you can always simplify numbers that are all alone. So negative 7 take away 2. I actually have negative 9. So now if we look at this simplified trinomial, there is something in common to each one, and that's a 3. I can divide each of those terms by a 3, but not by an x, because this last 9 has no x to give. Open up and divide. 6 divided by 3 is 2. Remember, we've taken out no x's, so no x's will change. 9 divided by 3 is 3. I still have that x tacked on, and negative 9 divided by 3 would be negative 3. Close it up. So always ask yourself if you can simplify. If it seems like you can't do anything, try simplifying first. And I gave you this last question because it's just all letters, no numbers. So when there's no numbers, well, there's all really ones out front. But like I've said a lot of times, ones don't really matter. We're going to look just at the letters, okay? So if we look at the C, whoops, if we look at the C's first, sorry guys, I want a different color. If we look at the C's first, I have 4, 2, and 3. So how many could each one give me for sure? Well, they could each give me C squared for sure. Okay, moving on, let's look at the D's. I have 3 there, 5 there, and 3 there. So they could each give me 3. They could each give me 3 without running out. Okay? So that's what I can take out. Each term is able to give me that much without overdrawing, without taking too much. Okay, so now that we figured that out, we subtract our letters. So with the first term here, I had C to the 4, but I took out C to the 2. So I have C to the 2 left. I'm not done. Let's just make sure we have nothing else here. This first term had D to the 3, but I took out D to the 3. So I took them all away. So they're all gone. So now I can move on. I had D to the 5, but I took out 3 of them. So I still have 2 left over. And then with the C's, I had 2 to begin with, but I took 2 away. So 2 take away 2 is 0. So I have no C's left here in this term. Moving on to the final term, I had C to the 3. I took out C to the 2, so I still have 1 left. And finally, D to the 3, take away D to the 3. I have 0 left. So that's what it ends up being. And like I always said, if you're stuck, distribute it back in and see if you end up with that, because you should. Okay? All right. Another little reminder, the text may reorder your terms. So for example, you might have it look like this in the textbook, like they just reordered them out here. It's no different because the C is still 2 and the D is still 3. Okay, so order doesn't matter as long as the exponents are still on the right letter. Okay, so the assignment is listed there for you, a textbook assignment. All right, do what you can. And of course, as always, you can message me on Remind or send me an email with the question you're having trouble with, and I can help you out. And when you come back to class, the next day you're in class, we can, of course, work on this as well if you're struggling. Okay, good luck.